Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 12, which reads, a resistor of 4000 ohms and a capacitor of 27 picofarads are connected in series. What is the impedance of the combination at 1.965 megahertz? So great, we've got to find the impedances and jam them together to figure out what our answer is. So for the resistor, that's really easy. The impedance is going to be 4000 ohms. The capacitor is a bit trickier because it is frequency dependent, but we've got a frequency, so we can apply our formula for capacitive impedance, which is XC is equal to 1 over 2 times pi times F, there's our frequency, times C, 1 over 2 pi FC. So let's jam that into our calculator and see what we can come up with. So we can do 2 times 3.141, sorry mathematicians, multiply that by our frequency, 1.965 times 10 to the 6th, turn that into megahertz, that gives us that, and then finally multiply by our capacitance times 27 times 10 to the minus 12, because pico is minus 10 to the minus 12. That gives us a really small value, but we then need to do the 1 divided by that, so we apply the reciprocal button here, which gives us about 3000 ohms, 3 kilo ohms. So the next step clearly is we just add that to our 4000 here, and we get our 7000 ohms. And unfortunately, that is a common pitfall that people fall into. And the problem is that the resistance is a scalar value, is just a single thing, is a simple value to work with. You can add a resistance to another resistance, no problem at all. However, impedances have an imaginary component, and the way I like to think of it is they occupy almost a different dimension. And if we look at the full license manual, we can see some examples of phasor diagrams which do a good job at illustrating this. So here is a diagram for pretty much for this problem that we're trying to solve, where we can see that the resistive part is going side to side on the x-axis here, and the capacitive part is along the y-axis here. So if we just added these together, they wouldn't necessarily give us anything meaningful. So what we need to do is actually figure out the product of both of these, which we get by walking a little bit like a vector. We go along by this amount and down by this amount, and we end up at this point here. And the way you would do that with a vector is with Pythagoras' theorem, which is illustrated here. So the length of the hypotenuse of a triangle is equal to the root of the square of both sides, and we can apply that to great effect for adding impedances together. So let's do that. So we've got 4000, so our total impedance is going to be the square root of 4,000 squared plus 3,000 squared. I'm really bad at these numbers, so square root of 4,000 squared plus 3,000 squared, so 4,123 squared plus 3,000 squared gives us 25,000. And if we then find the square root of that, that gives us 5,000 ohms, which is in fact option B. Option B, 5,000 ohms. So let's skip down to the answer key, see if we've got that one right. And we can see, in fact, for question 12, the answer is indeed B, 5,000 ohms for the sum of those two impedances. Thank you very much. I'll see you for the next one.